In designing the TOEFL detection project, the first major part of the project and the hardest part about it is obviously getting the machine learning system to work. And machine learning and artificial intelligence can seem like buzzwords for a lot of people. It's just stuff tossed around a lot of the time, and it's kind of hard to get into it and actually understand what it means. But at the very base of it, it's pretty simple. It's just allowing a computer to get training data and test data and essentially learn from that. Similar to how you would teach a child, you give it what training data so it understands what is a certain thing, and then you give it test data so it can check its own answers. And over time, it gets better and better at identifying it. So, and that's what my software does here. So as you can see, in the collected data, there's various sound files, either named TOF, speech, or noise. And yeah, I'll show you a noise. These are some noise samples, and they all vary in length from, let's say, like 1 minute to 12 seconds to 3 seconds. And having variety, obviously, in your test data is essential because you need to make sure you cover as much range as possible. And so one of the biggest issues here is that most test data online, at least, give you only noise and coughing. And that's just not enough, because if we want to actually identify sneezes and coughs as well, then we obviously need sneeze data. And a big part that this doesn't cover is speech, because the biggest issue I ran into first is that when I tested it, it recorded my speech as coughing, which obviously is terrible. That's not how it should work. But once that got patched out, it's relatively accurate. And once we actually design our machine learning model, we can see its accuracy here. So yeah, so here's a code that I tweaked a little bit in order to get this model. And this model is actually pretty interesting. It shows the feature and how it trained itself. So it shows the correct answers and the wrong answers. It also shows you the accuracy here for each single label. So for cough, it got it 90% of the time correct. For noise, it got it 98.8% correct. And for speech, it got 93.4% correct. So overall, it has a 96.3% accuracy. And that's good enough for our purposes. Of course, it's never going to be 100%, but we want to get it as close as possible. And honestly, for our purposes, 96.3% is good enough. And yeah, that's the biggest issue with machine learning that we need to finish for this project. And obviously, now that we have this code, we can implement it into an Arduino and begin the next step, which is actually configuring the hardware portion of it. Okay, so more cool things you can do with this software is that you can do some live classification things. And this not only allows you to actually test your data, but also allows you to use your phone and record yourself coughing or sneezing and see if it'll pick up on it. Obviously, this isn't really good for your health and your vocal cords, so it's recommended that you just find some samples online, as that's what we'll most likely be using anyways. So yeah, this is also an interesting feature of it. And when we're actually ready to deploy, we'll go to deployment right here, and we can create a library for what our purposes will be. And in this case, we will be using the Arduino Nano 33 BLE Sense. So that's what we will be doing next. And finally, one more interesting thing about the code that you can change is it's very customizable depending on what you want. So here you have your minimum confidence rating that you can change in the code as well. And this minimum confidence rating is essentially what confidence rating out of 1 does your model need to have before it classifies. So the higher it is, the harder it is for it to classify something as a top, for example. And this works as a double-edged sword, because if you make it like way too high, that means it'll never get it, because maybe it'll be like 0.75. And then even though that's correct, it won't mark it right if you put it as, let's say, 0.80. So that's one thing to consider. But if you put it too low, the opposite effect happens. So what happens is that it can be inaccurate and it'll still mark it as accurate. So you have to take that into account. And so I settled on 0.70 because it's a pretty good number. It's pretty accurate. As you can see here, there's only 0.35 loss and 96.3% accuracy. There's also various other things you can change, such as like window length, input length, and all these kinds of things, but that isn't too important. And the main library we're using here is TensorFlow. You might have heard of it before. It's very common in machine learning to use TensorFlow as a library. And so, yeah, we're using that one here as well, and it's working pretty well.